Welcome learners. In this lesson we shall look at the topic integration, mathematics form 4, and we look at the applications of integration to velocity and distance. And we say that suppose you are not given further information that can guide you to find the value of c. That is, maybe you're given one of the values but you're not given another value. So to evaluate c in that case, you have to remember the following concepts: that at maximum height velocity is 0, at maximum velocity acceleration is 0, at initial velocity distance is 0, and time is 0. You also have to remember that when a particle is momentarily at rest or stationary, velocity is 0, that acceleration due to gravity is always negative, and that to find the distance traveled during a certain second, for example the 8th second, you integrate with the limits from 7 to 8. That is, if you have been told find the distance traveled during the 8th second, you use the limits 8 and 7. Whereas if you are told to find the distance traveled during the first 8 seconds, you use the limits 8 and 0. And you also have to note that at initial acceleration, time is 0. The following is an example that elaborates on the concepts I've told you. It says a particle p moves in a straight line so that its velocity v meters per second square at time t seconds, where t is greater than 0, is given by velocity is equal to 28 plus t minus 2t squared. That is, you have been given velocity, and they tell you find a, the time when p is instantaneously at rest; b, the speed of p at the instant when acceleration of p is 0; c, they tell you find the acceleration of the particle p when the particle is instantaneously at rest; and d, they tell you find the distance covered by the particle after 3 seconds when t is 0 and d is 5 meters. So to solve this question, we say that we look at the first part, the time. You have been told find the time when p is instantaneously at rest. So when p is instantaneously at rest, you should know that at rest the velocity is 0. That is from the concepts you have been given. At rest velocity is 0, and you have been given your velocity, which is 28 plus t minus 2t squared. So in this case velocity is 0, so you equate to 0 28 plus t minus 2t squared is equal to 0. So if you look at the equation, you see that it is a quadratic equation. You use the quadratic formula to solve it. That is, you say time is equal to negative b plus or minus square root b squared minus 4 into bracket 4 times a times c divided by 2a. That is your quadratic formula. So you substitute the values. You say t is equal to, in this case our b is 1, so it is negative 1 plus or minus square root 1 squared minus into brackets 4 times negative 2, which is our a, times 28, which is c in this case, divided by 2 times our a, which is negative 2. So we say 1 squared is 1. We say 4 times negative 2, which is negative 8, times 28 is negative 224. So 1 minus 224 will give you 1 plus 224, which is 225. If you square root 225, you get 15. So you say t is equal to negative 1 plus 15 divided by plus or minus 15 divided by negative 4. You find two values of time. You find time is equal to, say, negative 1 plus 15, you get 14, divided by negative 4, you get negative 3.5 seconds. Or you get time is equal to, you say, negative 15 minus negative 1, which is negative 16, divided by negative 4, you get 4 seconds. Those are the two values, because you have been told to find time when p is instantaneously at rest. Those are two values of time. So part B says the speed of p at the instant when acceleration of p is 0. So you should know that when acceleration is 0, First of all, we need to find acceleration. That is, we have velocity. We have velocity, which is 28 plus t minus 2t squared, and we need to find acceleration. So we say acceleration is equal to dv over dt. We differentiate to find acceleration because we are going downwards. That is SVA going downwards. Yes. So for differentiation, when a number is constant, it is just 0. So it is t here. It will become, that will just be 1, right? So minus, you say 2 times 2, that is 4, and then you subtract the power from 1, that will become 4t. That is differentiation. So you have been told the speed of p at instant when acceleration of p is 0. So you have been told the acceleration is 0, and this is acceleration. So we equate this to 0. We say 1 minus 4t is equal to 0, and we get that 4t is equal to 1, and we get time is equal to a quarter seconds. But you have been told find the speed. So we know that velocity is equal to 28 plus t minus 2t squared. So what we do is substitute the value of t into the equation. We get 28 plus, this is t, right? A quarter seconds. You substitute a quarter seconds minus 2 into bracket a quarter squared. So what do we have here? We have a quarter squared is 1 over 16. So 1 over 16 times 2 is 1 over 8. 1 over 4 minus 1 over 8. 1 over 4 minus 1 over 8 is 1 over 8. So we have 28 plus 1 over 8. And velocity here is equal to 28, 1 over 8 meters per second. That is your velocity. So part C of the question says, find the acceleration of p when the particle is instantaneously at rest. The first part of the question said when the particle is instantaneously at rest, the time is equal to, we pick one value, that is to say the positive value, 4 seconds. And we said that the acceleration from the part B, 1 is equal to 1 minus 40. This is acceleration. So we have been told find the acceleration when particle is at rest. When particle is at rest, time is 4 seconds. And I need to find acceleration. I substitute the values. I say acceleration is equal to 1 minus into brackets 4 seconds. 4 times 1. So what do I have here is 4 times 4, I mean. That is 4 times 4. So acceleration is equal to, so 4 times 4 is 16. 1 minus 16. Acceleration will be equal to negative 15 meters per second square. That is acceleration due to gravity is always negative. So part D of the question. Part D of the question says, find the distance covered by the particle after 3 seconds. You have been given time is 3 seconds. And you have been told when t is 0, d is 5. So when t is 0, d is 5 meters. That is distance, is 5 meters. So how do I find distance? I find distance by integrating velocity. So I say distance is when you integrate velocity, but I already have velocity. The velocity is 28 plus t minus 2t squared, right? So I need to find my distance. So I say distance, I integrate velocity. So I introduce a t here. That is power of 1, 28t. So 28t divided by 1, that is just 28t plus, I have a t, right? So I give it, it has a power of 1, I add 1. So I get t squared. I divide it by the new power, I get t squared divided by 2 minus, I have 2t squared. So t squared, I add 1, I get t cubed. I divide by the new power, negative 2t squared, negative 2t cubed divided by the new power, which is 3. And I also have the constant of integration, which I don't have, that is c. But I have two values, that is 5 meters, that is distance, which is 5 meters, and time, which is 0. So I can use those two values to find the constant of integration. I say 5 is equal to 28 into brackets, I have my t is 0 plus, that is 0 squared divided by 2. So I have 2, that is 0 cubed divided by 3 plus c. So if everything here is 0, that means 28 times 0 is 0. 0 squared divided by 2, that is 0. 2 times 0 cubed divided by 3, that is 0. So I have C is equal to 5. So I get that the distance is equal to 28t plus t squared divided by 2 minus 2 over 3 t cubed plus 5. But I have been told find the distance after 3 seconds. So I substitute the value of 3 into the equation. So I say S is equal to 28 into brackets 3, right, plus 3 squared divided by 2 plus minus 2 over 3, 3 cubed plus 5. So I get distance is equal to 28 times 3 is 84. 3 squared divided by 2, that is 4.5. I say 2 over 3 times 3 cubed, that is 18, minus 18 plus 5, that gives me 75.5, and that is in meters.